A, B, and C be positive real numbers such that ABC equals 1. Prove that A minus 1 plus 1 over B times B minus 1 plus 1 over C times C minus 1 plus 1 over A is less than or equal to 1. The first step is to simplify the fractions using ABC equals 1. For example, 1 over B equals AC and 1 over C equals AB. Then, the first two factors of the left-hand side of the equation can be simplified. 1 over B is replaced by AC and 1 over C is replaced by AB. Expanding the multiplication using distributive property, we have 3 terms times 3 terms, and we end up with 3 groups, total of 9 terms. In the last group, we have ABC, which is 1. A squared BC equals A. Now, we have a positive AB, negative AB cancelled. Negative A, positive A cancelled. Positive 1 combined. As a result, there are only 4 terms remain. A squared B minus B plus 2 minus AC. Grouping the last 3 terms, it is actually a perfect square. Root B minus root AC squared. A quick check. Root B minus root AC squared equals root B squared, that is B, 2 times root B times root AC, that's 2 times square root of ABC, and the last term, root AC squared, that is AC. And we know ABC equals 1, so it equals B minus 2 plus AC, B minus 2 plus AC. Now, A squared B minus a perfect square which cannot be negative, so it is less than or equal to A squared B. On this page, we proved the first factor times the second factor is less than A squared B. We can establish similar inequalities for the second factor, the third factor, and the third factor multiplied by the first factor. It seems that if we multiply the 3 inequalities and the right-hand side a cubed, b cubed, c cubed, which is 1, we are done. But just be careful. When we do the multiplication, we have to bear in mind the inequality sign might be switched if some of the values are negative. Here's an example. Negative 1 is less than 1 and negative 2 is less than 1. But when they multiply them, negative 1 times negative 2, which is 2, greater than 1 times 1. Fortunately, at most, one of the 3 factors can be negative. In other words, if one of them is negative, the other 2 must be not. If this is the case, we are done. The first scenario, if all 3 factors are not negative, then we can do the multiplication of the 3 inequalities. The inequality sign remains the same direction, and the right-hand side is a cubed, b cubed, c cubed, which is 1. We are done. Scenario 2, if one of the factors is negative and the other 2 are not, then their production cannot be positive, which is of course less than 1. The proof of the claim is straightforward. Assume the first factor a minus 1 plus 1 over b is negative. Then a plus 1 over b is less than 1. Both a and 1 over b are positive numbers. The sum is less than 1, meaning both a and 1 over b are less than 1. Equivalently, their reciprocals 1 over a and b are both greater than 1. Then we can easily see both the second factor and the third factor are positive. Thank you for watching.